Hello everyone, in this video we'll be solving problem 283 move zeros. The problem statement is given an integer array nums, move all the zeros to the end of it while maintaining the relative order of all the non-zero elements. Note that you must do this in place without making a copy of the array. Looking at example number 1, we have several numbers including zeros, and if we move all of these zeros to the end, the output array would look something like this, starting with 1, 3 and 12 followed by 0 and 0. In example number 2, we only have 1 0 in the input array, so the output is the same, no changes. As a follow-up, the problem statement is asking us to minimize the total number of operations done on the array. I hope you were able to understand the problem statement. Let's switch to whiteboard and discuss a couple of solutions, starting with the naive approach followed by an optimized one. In the naive approach, we can start by iterating through the input array, identify all non-zero elements, and move it to a new collection or array. After completing this operation, we know the size of this new array and we know the size of the original array that was given to us. So whatever is the difference, we can populate or fill them with all the zeros at the end and replace it with the original input array. If we were to take this approach, our time complexity would be O of n, where n is the size of the input array, and the space complexity will also be O of n, as we are creating this extra collection to maintain all of the non-zero values during the iteration. As the problem statement is asking us to do an in-place operation, this solution is not acceptable. So now let's think about how we can improve this solution using in-place operations. One way to solve this problem is using two pointers. The idea is that we need to first move all of the non-zero elements to the start of the array, and whatever are the empty spaces left at the end will be pre-filled by 0. And instead of creating a new array to maintain all these non-zero elements, we'll instead copy the value into the same input array, replacing all existing values, whether it be a non-zero element or a zero element. The intent of doing that is to make sure that we are not losing any of the non-zero elements during the iteration. As we are distinguishing the numbers between zero and non-zero categories, during the iteration, if we make sure we record the count of the total non-zero elements, we can easily populate the remaining elements in the input array with zeros at the end. Let's do a couple of simulations to understand how will this work. We'll use two pointers I and j for the simulation. We'll use I to iterate through all of the elements in the input array, where j will be used to point at the position where the number I needs to be copied to. So j pointer should not be incremented if I is pointing at a value which is a 0, as we don't want to copy a 0 value into the new array or move it to the left. We'll start the iteration with both I and j pointing at 0. As the value at I is equal to 0 is a 0, we will not do any copy operation and the state of the array will remain unchanged. For the next run, we'll increment the I pointer, leaving j as is. As discussed earlier, j will only be incremented if I is pointing at a value which is non-zero. With I is equal to 1, the value is 1, which is a non-zero. So we'll copy the value into the jth position and increment both the pointers. For the next run, I will be 2 and j will be 1. I is pointing at a 0, so we will not do any copy and not increment j either, and continue with the next run. With I is equal to 3, the value is 3, which is non-zero, so we'll repeat the same cycle of copying the value and incrementing both the pointers. So the updated state of the array would be, for the last run, I is pointing at 4, whose value is 12. As it is non-zero, we'll repeat the same cycle of copying the values and incrementing both the pointers. As we iterated through all of the elements in the input array using I pointer, we'll use the j pointer to prefill all of the remaining zeros into the input array. We can simply start a for loop starting from the j position until the end of the array and save or set the value as 0. So once this for loop is complete, the updated array would look something like this. With this solution, our time complexity is O of n, And our space complexity has been improved to O of 1 as we are doing in-place operation and not creating any additional collection. Let me show you how we can implement this using C#. Here is my C# solution. I start by initializing my second pointer j, setting it to 0, and then starting a for loop with I pointer. If the element that I is pointing at a non-zero value, then I'm copying the value and saving it into the j position and then incrementing my j pointer. Once this for loop is done, then I'm running another for loop starting with j all the way to the end of the array and setting all of the values as 0. Once the iteration is complete, I will have all of the non-zero elements move to the left side of the nums array. This code, when submitted on LeetCode, beats 97% of the submissions in terms of runtime and 35% in terms of memory. Thank you for watching this video. I hope you were able to understand this explanation and the code. The link to the code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.